Okay, we're looking at a physics problem in momentum and collisions that has to do with a slope or around a ramp type structure where we have a mass of 10 kilograms, a ball at the top that is not moving right now, and then we have down here another ball that is has a mass of 15 kilograms. So what happens in this problem? We want to find out when this ball, and we'll call this right here ball 1, and there's ball 2. Okay, when ball 1 is let go, it has energy, it has stored energy, potential energy, and it's going to roll down, it's going to collide with ball number 2, and then it's going to go back up so far. And what we want to find is we want to find how high will it go. Right now it's situated at 10 meters above this level of ball 2. So how do we figure out a problem like this? Okay, well, the first thing we need to do is we need to take a look at what is the potential energy of ball number 1 in its position. This is a conservative problem. Energy is conserved, kinetic energy and potential energy. So if that's the case, then we know that potential energy plus kinetic energy is equal to 0. So let's find the potential energy of the ball 1 in its position. So potential energy, we'll call this 1, is equal to 10.0 kilograms times 9.8 meters per second squared, and the height, 10 meters. Okay, so we have our potential energy in our first position is going to be equal to 980 joules. Okay, so with that is our energy, potential energy, and that potential energy will be equal to kinetic energy. So what we need to know is that when this ball rolls down, it's let go, and it collides with ball number 2, we want to know what is its velocity. We'll put V1 right there. Okay, so what is its velocity? Well, this is step number 1. Step number 2 is to find V. So we want to find V1. Okay, and we can use the kinetic energy equation. Okay, and we can just solve using algebra, solve for V. Okay, and V is going to be equal to the square root 2 times the kinetic energy divided by the mass. Okay, so let's do that. Two times 980 joules divided by the mass all under the radical. Okay, and this is going to be equal to 14.0 meters per second. Okay, and so that is the speed in which ball number 1 will hit or collide with ball number 2, which is, by the way, ball number 2 is at rest. Alright, so now we need to go to step number 3. And step number 3 is going to be using, we'll place this right here, it's going to be using our momentum. This is a elastic collision. And so we're going to be using this formula. Okay, so we have our first mass, m1v1 plus m2v2 is equal to m1v1 prime and m2 plus m2v2 prime. And so this, we don't really care about this answer right here, v2 prime. That's the second ball that is down the ramp, but we do care about this answer right here. Okay, v prime 1, and that's what we want to find. Okay, so there's lots of ways to solve this equation, and one of the ways is to use a formula. I'm not going to go through that because my goal here is to solve this problem here. But let's just take a look at how we would set this up anyways. So first of all, m1v1, it has a velocity. So m1v1 plus 2 is 0 is equal to m1v1 prime plus m2v2 prime. Again, we're not interested in this term right here, but we are interested in this. So we take our equation. To find the two different two variables, you need two equations. So we're not going to go through that, but I'm going to give you what the answer is, so we can go from there. So this is actually the third step. Okay, so now that would give us an answer of, for v1 prime would be equal to negative 2.8 meters per second. Okay, so that's the solution you would get. And that would mean that in this problem, this v1 prime, the v1 is the ball going down, but when it goes back up, when it leaves that area, it's leaving at minus 2.8 meters per second. Okay. Let's keep on going here. All right. So what's the third step? Well, the third step is now with the new velocity going in the opposite direction, we want to know how high it goes up. Okay. So let's take the to the fourth step, and we need to find energy. Specifically, since we have a velocity, let's find the kinetic energy going in the opposite direction now. So kinetic energy 2, we'll call that 1/2 mv squared. And this mv squared will be actually prime, and then it'll be actually 1. So let's solve for that. So we have 1/2 the mass of 10 kilograms, and then we have minus 2.8 meters per second squared. And this gives us a kinetic energy of 39.2 joules. Okay. So that's the energy in the opposite direction. So after the collision, the ball, after it collides with ball number 2, it's going to go up. And we want to know how far up it goes from this point. Okay, we have 10 meters it was dropped from, and it's going to go up here so far. We need to know, we're going to calculate what that distance is. Okay, so this is step 5 in the problem. And so to calculate it, we need to find H2. So we look at this height, this is actually H1, okay, where it's being dropped from. But as the ball goes back up, it's going to go over here somewhere, okay, and that height is what we're looking for. That height is going to be our H2. Okay, so how do we find H2? Okay, well, H2, since the potential energy in this problem, because it's conservative, is equal to the kinetic energy. Okay, so if that's the case, then 39.2, our energy was 39.2 joules. Okay, so we can use the potential energy equation to find the height. Okay, and that's potential energy is equal to mgh. That h is what we're interested in. Okay, so h is going to be equal to the potential energy divided by the mass and g. Now this potential energy right here is equal to the kinetic energy, so but we're just actually, what we're doing is that we're going to borrow the potential energy equation to find h. So this is equal to 39.2 joules, all divided by the mass of the first ball, and times our acceleration of gravity, 9.8 meters per second. Okay, and so let's solve that. So our h, we'll call this h2, is going to be equal to 0.400 meters. Okay, so we don't have to worry about negative or pluses here because we're working with energy basically. Okay, so we know which direction things are going, and when we did find the velocity of the ball after impact, the first ball, and it was on its way up, it did give us a negative sign showing the direction. Okay, but all this was squared out of it because of the equation of kinetic energy. So anyways, this is how you do this type of problem right here, and I hope it's helpful.